G'day. Copy the heading down and then we'll do some hard yakka. Our big space telescopes reveal a universe of galaxies of all shapes and sizes. There are 100 billion galaxies, of which this is just one fairly close one. The stars in this image are a few of the 100 billion suns in our galaxy, which we call the Milky Way. Each sun is an element creator, constantly fusing hydrogen and small element nuclei in its hot core to form the nuclei of heavier elements. Not all of the hydrogen in a sun is used. Suns end their life cycles with a massive blast of energy in a nova event. Distant stars, invisible to human eyes, will suddenly appear bright in the sky. The word nova is a Latin word which means new. Chinese and Arab astronomers were astonished to see the Crab Nebula supernova in their sky in 1054 AD. This remnant, 6,500 light-years out, is a picture by the Hubble Space Telescope. Danish astronomer Tycho Brahe recorded this supernova in 1572. It is 7,500 light-years out. Every video needs a hero, so I present to you Dmitry Ivanovich Mendeleev. The grandson of a Russian Orthodox priest, Mendeleev was born to a large family in the harsh environment of East Siberia. He should have died of tuberculosis, but instead moved to St. Petersburg, where he became Russia's most famous chemist. He was a real character, eccentric and popular teacher who pushed for social reform, travelled third class on the trains and cut his hair once a year in the shearing season. He was one of two people who recognised in 1871 that elements can be classified into 8 main columns of similar elements. You should study the modern periodic table of the elements and have your own personal copy. The model for our element atoms was largely worked out 100 years ago by Cambridge University physicists led by New Zealander Ernest Rutherford. Atoms are like ghosts with mostly empty space. Most of the mass of an atom is locked up in the nucleus, which is 100,000th the diameter of the atom. The nucleus contains positive protons and neutral neutrons. The positive protons are exactly balanced by the tiny negative electrons that occupy shells around the nucleus. This element, lithium, is element number 3 in the periodic table. So it has 3 protons and 3 electrons. You might think that such neutral elements are chemically stable, but this is not the case. The universe is designed for change. If you want to form rocks and the complex chemicals of life, then you need your atoms to be somehow sticky, with a built-in need to bond with other atoms. In this table of the first 20 elements, only the column 8 elements are stable. The rest are under a tension, with a desperate need to combine with other atoms. Most elements need a full outer shell to be stable. Lithium metal gets rid of its outer electron to do this. Unstable lithium atoms become stable lithium ions. You should find formula writing easy once you know the element valencies. Write down this definition under your heading. You will be given a periodic table in all your major exams. It contains clues with valence. Look at the valence numbers at the bottom. 1, 2, 3, 4. Group 5 is uncertain. Then 2, 1, and 0 for the noble gases because they don't combine with anyone. Take a whole new page and fill it with this table of 3 columns. In the first column, write these 4 metals. Remember, the second letter must never be a capital. In the second column, write these nonmetals. In the third column, write these radicals. The numbers are at the bottom. Rule off and write these metals in the first column under valence 2. These two nonmetals go in the second column. These two radicals go in the third column. Rule off, the heading is valence 3. In the first column, write these two metals. Nothing goes in the second column. In the third column goes phosphate. Rule off, the heading is valence 4. These two nonmetals go in the second column. Columns 1 and 3 are blank. Rule off, the heading is valence 5. Nitrogen and phosphorus go in the second column. The table is now complete. Well done. Copy these simple rules down and we'll turn you into competent chemists. Before we start, we should remember that when a nice non-metal girl marries a handsome metal boy, that she changes her name to an IDE word. If we wanted to completely wreck our lungs, we could make this pretty copper fluoride compound by heating copper in an atmosphere of fluorine gas. To write its formula, we write the symbols for copper and fluorine, with the valencies at the top. Then we cross the numbers over. Finally, we rub out any ones in the formula which are understood. Copper fluoride is an ionic compound with 1 copper and 2 fluorines. Dangerous sulfur dioxide chemicals in the air of cities and towns will gradually change shiny silver to black silver sulphide. This chemical is the same as the silver ore mined at Broken Hill. Please use your crossover rule to work out its formula. Now for the solution. We write the symbols Ag for silver and S for sulfur. We write the valencies as superscripts. We cross them over to get Ag2S1. Then we rub out the 1 to get the final formula Ag2S. 2 Aggies and a sulfur, which sounds a bit smelly. One extremely dangerous experiment is to heat the reactive metal aluminium in a tube containing bromine liquid. Eventually they react, forming aluminium-bromide, which is a white salt. Work out the formula for aluminium-bromide. Aluminium has a valence of 3 and bromine 1. We cross them over to get AlBr3. The banded iron formation from the Hamersley Ranges in Western Australia contains the ore mineral hematite, or iron 3 oxide. We export trainloads of this in the world's biggest ships. Note that iron has 2 valencies in our table, and this one must be shown. It is also called ferric oxide, the suffix "ic" meaning the higher valency, and the suffix "aus" the lower valency. Work out the formula for iron 3 oxide. When we cross over the valencies, we get Fe2O3. Time to accelerate. We will give you 5 chemicals and mark them at the end. We move on. Copy down this rule under the heading Set 2. In our first example, we look at the common mineral quartz, found in beach sand. I would call it silicon oxide, but silicon dioxide is in common chemical usage. Using the prefix di, they are telling you that there are 2 oxygens in the final answer. We start by writing in the valencies Si4 and O2. Our new rule says to divide those numbers by the highest common multiple, which in this case is 2. When we divide, the 4 becomes 2 and the 2 becomes 1. The rest is as before. We cross the numbers over and rub out the 1. Have a go at this deadly poisonous chemical. We will give you another 4 and give you the final answers at the end. Write this down as the final rule for writing formulae. A radical is a group of atoms with a single name. The numbers in radicals should never be changed when working out formulas. We are asked to work out the formula for calcium carbonate. Both calcium and carbonate have valencies of 2. So we apply our cancellation rule in set 2 and divide both these numbers by 2. We end up with 2 1s which we cross over. Then we rub out the 1s. The radical does not need to be bracketed. Our second example is ammonium sulfate, which contains 2 radicals. Ammonium has valence 1 and sulfate 2. We cross these valence numbers over. The ammonium is bracketed with 2 outside the brackets as a multiplier. The brought down one is rubbed out and the sulfate radical is not bracketed. There are 2 times 1 nitrogens and 2 times 4 hydrogens in this formula. The 2 outside the brackets is a multiplier. Radicals are the hardest skill to master in formula writing. We will give you a few to do and answer them with each change. With practice you'll get them right every time. Till next time, cheerio.